Hello everyone. In previous lecture we already discussed what is meaning of vapor pressure and what is relative lowering of vapor pressure and what is lowering of vapor pressure. All things we already discussed. That is because of addition of non-volatile solute in pure solvent, vapor pressure of pure solvent decreases, which is nothing but lowering of vapor pressure. And we already discussed this lowering of vapor pressure is a qualitative property. That is, it depends on number of particles present in solution. And that means that magnitude of lowering in vapor pressure is directly proportional to x2. That is, x2 is mole fraction of solute in solution. And the quantitative relationship between lowering of vapor pressure, relative lowering of vapor pressure, magnitude of lowering of vapor pressure, and that amount of solute added, that relation between these two things is first given by Raoult's law. All these things we already explained in previous lecture. In today's lecture we discuss experimental method for determination of, for measurement of lowering of vapor pressure of solution. Experimental method for determination of lowering of vapor pressure of solution. That is, when solute is added in solvent, its vapor pressure decreases. Then, by adding the specific amount of solute, how much that vapor pressure of solvent decreases, that one is to be here calculated by using experimental methods. There are two methods for measurement of lowering of vapor pressure. First method is static method and another method is dynamic method. We discuss first static method for determination of lowering in vapor pressure. In this method, the two manometers are used and that are connected to U-tube, and that two manometers, two bulbs, contain the volatile solvent and solution of same solvent. Here considered solvent is N-butyl phthalate or beta bromo naphthalene that are commonly used for in this method. In this method, that in first bulb pure solvent is used, is filled, and in second bulb that solution of same solvent is filled, and by with the help of using that vacuum pump first, that all that vacuum from the with the help of that U-tube, all that vacuum from pipe is removed by opening that T1 and T2 knobs, and by removing that vacuum, that level in a manometer, two side levels at the solution side and at the solvent side, that level is first constant, same level. Afterward, after removing that all vapor from that inner pipes, close that T1 and T2 tab and After some time, measure the level difference in that manometer. That indicate that at the side of solvent, that level is less as compared to solution side. That indicate that in a solvent, in a pipe above the solvent level, there is more vapor collected, and in a solution side, level is above, manometer shows level up. That indicate that in solution side less vapors are collected, and that difference between these two levels gives the difference in that is lowering in vapor pressure, that is P0 minus PS, that is vapor pressure of solvent, pure solvent, minus vapor pressure of solution. That difference is nothing but equal to difference in level difference in that two side arms of manometer. Then second method is a dynamic method. Dynamic method. This dynamic method that have been more extensively used, and it is more accurate and easier than that of previous method. In Ostwald-Walker method, a stream of dry air, that is that Ostwald-Walker method is nothing but it is known as dynamic method. And in this method, stream of flow of dry air is first passed through series of bulbs containing the solution. That is, first that dry air is passed through series of bulbs, series of tubes containing solution. During this passage, what happened? Air is initially dry, but during the passage through the solution, it becomes saturated with vapor pressure of solution. In dry air, vapors of that solutions get mixed up to a level, up to certain level, which is equal to vapor pressure of solution. And therefore, the dry air become saturated with vapor pressure of solution during the passage of dry air through that solution. Then the loss of vapors from bulb, that is from that solution tubes or solution bulbs, how much vapor of that solutions are mixed in dry air, we can calculate that by weighing the tubes, that solution side tubes only, that weighing the tubes before and after the passage of dry air through that tubes, that before weight and after weight, which one is more? Here loss because of the passage of dry air, that dry air remove some of the vapor from solution, and therefore loss in weight takes place, and that loss in mass of solution side is proportional to, directly proportional to, that is equal to vapor pressure of solution, and that is equal to delta W1, which is loss in weight of solution side tubes, is proportional to vapor pressure of solution, that is PS. Then next part of this experiment, same air which is already passed through solution tubes and which is already saturated with vapors, which is equal to vapor pressure of solution. That same air is after or passed through another series of tubes, that is two tubes containing previous containing pure solvent, and that solvent tubes are also previously weighed. That weight is also actually taken, that is before passage weight, weight of solvent side tubes. And then after passage, what happened during passage? We already known that vapor pressure of pure solvent is always greater than vapor pressure of solute, and therefore during passage some of the vapors again mixed in that dry air, and therefore loss in vapors takes place in a solvent side tube also, and therefore that loss in vapor pressure is equal to, which is proportional to vapor pressure of solvent, and that can be measured by weight difference, that is after passage that that weight is noted, weight of that two tubes is noted, and that difference in weight, that is delta W2, is calculated, which is weight difference before passage and after passage, and that delta W2 is proportional to that is vapor pressure of solvent, vapor pressure of pure solvent, and from that also proportional to that vapor pressure of difference in vapor pressure, that is relative lowering of vapor pressure, that is from that weight delta W2 we can calculate lowering in vapor pressure, that is W, that is P0 minus PS, P0 minus PS, that delta W2, which is nothing but P0, that is vapor pressure of pure solvent minus vapor pressure of solution. This finally the air which is passed through solution and pure solvent is finally passed through next series of U tubes, which contain calcium chloride, which is substance used to absorbent, that is used to absorb vapor from that dry air, and that after passing that wear through this calcium chloride tube, that absorb all vapor from that air, and therefore mass of U tube solution, that is calcium chloride solution, is increases, and that is proportional to increases in, because that one is absorbed, vapors are absorbed in calcium chloride tubes, therefore mass in calcium chloride tubes increases, and that mass increase in mass of U tube, calcium chloride U tube is determined, it gives the total loss, that is delta W1 plus delta W2. This loss total loss in mass, is measure the vapor pressure of, it measure the vapor pressure of saturated air up to pressure P0, that is solvent vapor pressure, and therefore relative lowering in vapor pressure, that is P0 minus PS upon P0, that is decrease in vapor pressure upon vapor pressure of pure solvent, that is nothing but relative lowering, which is equal to that one can be calculated as delta W2 upon W1 plus delta W1 plus delta W2, that values of delta W1, delta W2, that are calculated from experiment we seen here, and by using these values, here we can calculate relative lowering in vapor pressure and lowering in vapor pressure of solution. Thank you.